for your exponent laws, if there are any that you don't remember, you can always figure them out by going back to what is the definition of an exponent. If you have 3 squared, it means what? 3 times 3. So if you had 3 squared times 3 to the 4, this one means 3 times 3. This one means 3 times 3 times 3 times 3. Does it make sense that you should add the exponents?
Yes.
Okay? Each of these rules, if you go back to the definition of what is an exponent, you should be able to say to yourself, that rule makes sense to me. Now, once you've got the rule, then you can use that rule in situations that's harder, like fractions. It's hard to picture what half x to the half is, because our exponent rule, like our definition, seems like, oh, I know that it's repeated multiplication, but how can I repeat something half? So it's a little bit harder to visualize. But once we know what our rule works, what happens when I add 1/2 plus 1/2? Get x to the 1, which is just x. Radicals. What was the rule for multiplying radicals? This is going to equal x squared. And squaring and square rooting are opposites, right? What's going to happen when you square root something you square? It's just going to cancel each other out, and you'll just get x. The answers are the same. Do you think that the square root of x is equal to x to the 1/2?
Yes.
Does it seem logical that that would be, looking at this pattern, that this would be something you might argue? That the square root of x is equal to x to the power 1/2, according to what we saw as a result here. Let's try it with a number. Let's try the left side by multiplying those, the right side by using your exponent laws, and see if it still works out to be equal. Because the question we wonder, is the square root of 1/3 equal to, question mark, 1/3 to the half? Well, if I multiply these together, I'm going to get 1 times 1 is 1. 3 times 3 is 9. Square root of fraction is the same as square root of the top and square root of the bottom. So we get 1/3. And here the bases are the same, so we can add the exponents. 1/2 plus 1/2 is 1/3 to the 1. They are the same. So it appears that a square root is the same as a power of 1/2. And it is. Oh, too fast? Oh, let me know when you're done. You're done? Taylor, done? Almost done? So here is the general rule, and a has to be bigger than 0 because you can't take the square root of a negative. You're not allowed to use a phone during a test. You can use your graphing calculator, though. I'll lend you one. There you go. Yes. Split it up. We'll do this one there. Will they be equal? This is our big question. Is the cube root of 5 equal to 5 to the 1/3? We have to do the math to find out. And then we're going to use our calculator to do something else, like the 4th root of 7. Type that into our calculator. And we're going to see if it's equal to 7¼ But I do want you to practice typing that in to your calculator to see if you can actually get that. For that one, yes. For these ones, no. What happens when you get 5 times 5 times 5? 125. And here, the bases are the same, so you could add the exponents. What is the cube root of 125? 5. And what happens when you get 1/3 plus 1/3 plus 1/3? You get 1, so 5 to the 1 is just 5. So they are the same. Check out your calculator. Are you able to type in the 4th root for math? Go down to number 5. Push enter. 4th root of 7. Get a value. And then type 7 to the power 1 divided by 4. If you have an older calculator that doesn't actually move those values up, you'll have to do 7 to the power, and you'll have to put the 1 divided by 4 in brackets, not 14. Whoa, it still didn't get my divided by 4. Okay? If you wanted, you could also put things into fractions. 7 to the power 1/4 that way. You get the same answer. Mm-hmm. Go back again. Excuse me. Wait till the people watch it on video. Headphones in. We're just doing the one on the 4th root for math. Go down to this 4th root 7, enter.
So wait, you go second.
No, you just hit the math button to get. Yeah, clear it. Try it. Okay, here we go. Next one. Yeah.
Why is there only 1 5 on the right side when you have like
Because these exponent rules. Exponent rule says if the bases are the same,
Oh yeah, okay.
then you add the exponents. So how could you write a to the 1/2 as a radical? It would be the square root of a. How could you write a to the 1/3 as a radical? Cube root of a. This will be the 4th root of a and the 5th root of a. And here you get to use one of your fancy letters, your n with 2 lines. I usually did the n with 2 lines here. Natural numbers. So here's some math terminology. A to the 1 over n is equal to the nth root of a. So you have to learn how to read math as well, where n is a natural number. So this part right here says n is a natural number. Mathematicians don't like to write a lot, so they develop short form because that comes up quite a bit when you have to define what kind of number something is. This symbol that looks like an E is actually an element of, n is an element of the natural numbers. That's where that symbol comes from. But people often read it as n belongs to the natural numbers, or n is an element of the natural numbers, or just n is a natural number. The word evaluate, so make sure when you're looking at this, the word evaluate means get an answer. Get a number as a final answer. So 49 to the 1/2 is equal to? 49. No. Oh, 7. It's equal to 7. Because that 1/2, if you think of it like this, then you might be thinking of 7 a little bit quicker. 49 to the 1/2 is the same as the square root of 49, which means that it's equal to 7. Negative 27 to the 1/3. Negative 3. You are allowed to take cube roots of negative. You can't take square roots of negative, but you can take odd power. Only even powers of negative numbers are not allowed. Because negative 3 times negative 3 times negative 3 is? Negative 27. So you can take a cube root of a negative.
But if you did a square root,
The two negatives would be positive, and that would be a problem.
Well, it would still be something.
the square root of negative 9 is
Square root of negative 9 is not possible. Because if you think negative 3 and negative 3, you get positive 9.
and then
If you did 3 and 3, you'd get positive 9. And if you did negative 3 and 3, the numbers aren't the same. So then it's not a square root.
so it's a paradox.
And if you use imaginary numbers, it would equal 3i. Maybe in second or third year university. Cube root of negative 8 is? Negative 2. Good job. Now all of these ones were fairly straightforward because the fractions were nice, 1/3. But what would happen if you wanted to do something like 32 to the 2/5?
Then you do 1/5 and add another 1.
Possibly. 2 1/5? You could do that. So how would you write that?
32 1/5 plus 32 1/5, or if we multiply.
Or would it, is that a correct statement? Are those equal?
Yes, those are
Okay. That would have to be timesing, right? Because our exponent laws say when the bases are the same, we add the exponents. What is 32 to the 1/5?
let's say 2.
Good. 2 times 2 is 4. So 32 to the 2/5 is 4. Another way we can think about doing that is remembering our power law. Again, you can figure this out. Again, you can figure this out by going back to the definition of what an exponent means. 3 cubed means 3 times 3 times 3. So 3 cubed squared would be 3 times 3 times 3 squared. And squared means so there has to be 6 of them. How could you go directly from here to here? By multiplying your exponents. Okay? That's what the power law is. So here I have x squared to the power 4, would be?
The x to the exponent of 8, or the power of 8.
Nice. What we're going to do is when we get things like your method of 1/5 and 1/5 works fine, but if it was something like 32 to the 8/5, how many 1/5 would you have to do? 8 of them. So it might be rather long to write.
32, do you want the answer? 1/5, that's equal, that's a whole number.
Right? We figured out 32 to the 1/5 was already equal to 2, right?
Okay, yeah.
And if you did 8 of them, you'd have 2 times 2 times 2 times 2 times 2, 8 times. If you did one of them, here's one of them, 8 times, right? Exponent law here says, power law says multiply, but how do you multiply fractions? You make 8 as 8 over 1, multiply the tops, multiply the bottoms. That's the same as 8/5, but then you can say, I know 32 to the 1/5 is 2, and then I have 2 to the 8, and 2 to the 8th is? Good.
One sec.
Okay.
128, and then you times that by 2.
So 32 to the 8/5 is 256. That sounds impressive. Go home tonight if your parents still ask, what did you learn today? You could say, right, you normally say nothing, right? You say that at what grade do you start saying nothing when they ask you, what did you learn today?
Like 5.
Grade 5, grade 6? And then you keep saying nothing until they stop asking, right? Do they still ask any?
Yeah.
A little bit? So now you can say, just save this one. What did you learn today? And you can say, oh, I learned 32 to the 8/5 is equal to 256. Okay. Evaluate.
I was like, Mom, I learned something today. She smacked me. She's like, that won't be here in this house.
Let's just hope that sometimes the video doesn't get all of the information. Just here's me. The information in the background is usually quiet, right?
Although it did catch
So you can either think of this as 4 to the 1/2 3 times, like that, or what we did before is 4 to the 1/2, 4 to the 1/2, 4 to the 1/2. They're the same thing. But depending on how you're visualizing it, someone else in the other class said, isn't this the same as 4 times 4 to the 1/2? Those are all the same, aren't they? Four to the 1/2 is the square root of 4. That's equal to 2. So here it'll become 2 cubed. Here it would become 2 times 2 times 2. And here it would become 4 times 2. Either way, you get 8. Generally speaking, as if you're looking for like what method should I use, this tends to be an easier method to go to quickly. It doesn't take very much to write. You can always, here I'll just add one more arrow here. Can you see that you could have also done 4 with the 3 inside and the half on the outside? Okay. That works as well, but the problem by putting the bigger number inside is your answers get bigger rather than smaller. Like the square root of 4, it's easy to figure out that's 2, and then 2 cubed isn't so bad to get to 8. 4 cubed is? And the square root of 64 is? 8. So it works as well, But can you imagine that last example that we had? Where we 32 to the power 8 if you did that first? Oh, yes. So 32, 32, 32, 32. Pretty big number. And then take the fifth root of that big number. Oh, and then it's 256. Perfect. Wonderful. Okay. 32 to the 2/5. Try this one on your own. We did 8/5. This would be easier. So I would suggest starting with the 1/5 here, squared outside, 32 to the 1/5. And that's just basically prime factorization, right? So that's where that prime factorization, lots of mental math come into play here. To see that that's 2, you'd still have squared on the outside. 2 squared is 4. If you think of the prime factorization, if you think of 32 is 2 times 2 times 2 times 2 times 2. See there's 5 of them? Can you imagine what 2/5 of that would be? You see that's 4? Isn't that cool? Can you see if you did 3/5, 32 to the 3/5, you'd get 8? 32 to the 4/5? It's a little bit harder to do to the 8/5 because, like when we did 32 to the 8/5 earlier, that 32 is 2 times 2 times 2 times 2 times 2, right? That's 32. Times 2 times 2 times 2. That would be 32 squared. 8/5 would be that many of them, right? So this still is better, the left-hand side. But this is pretty cool when you're doing numbers less than, like a fraction like 2/5 or 3/5 or 4/5. So here's the general rule. A to the m over n is equal to a to the 1 over m to the m is the nth root of a to the m, where a is greater than or equal to 0 if n is even, because you can't take an even root of a negative number. And important in this is that the fraction must be reduced in lowest terms. What's that? Sure, I can zoom in a bit. How's that? Now, there's a reason why in the last slide we said m over n needs to be in lowest terms. And this is a great one for discussion for that. Because if you didn't say it had to be in the lowest terms, and you just went about the technique, you would go -8 to the 1/6 first, right? And then squared. That would be the thing that we've generally been doing. But if you try -8 to an even power, the 6th root of -8 squared, this is not possible. Okay? Yes?
So you would reduce it to 1/3.
If you reduce it to 1/3 first, -8 to the 1/3 is the same as the cube root of -8, which is -2. If you didn't reduce it, but you squared it first, -8 squared, and then did to the 1/6, -8 squared is 64, positive, because a negative times a negative would be positive, to the 1/6. And the 6th root of 64 is +2. So the correct one, and that's the reason they say make sure it's in lowest terms first, is this one. So here's a new order of operations in BEDMAS. You have to like lowest terms it first. Did I just make that into a verb? I did. Lowest term it. You have to, yeah, but I made it a verb. It's officially. So once you're done lowest terming, then okay. One of the things that I want you guys to focus on, and sometimes you don't focus on this very much during class, you write out the question, convert to exponential form, then you wait for me to do it, right? Then you say, okay, well, the fourth root is to the 1/4, and doing our exponent laws, right? 3 times 1/4, multiply your fractions, 3 times 1/4 would be 3/4, and now you've written it as a fraction. And what happens in class is you see me go from here to here, and you say, okay, that makes sense, and you don't pay any attention to this. On the test or on the quiz, that's all you get is the instructions. So one thing I want you to make sure you're doing during class, and this is true for any class, is you pay attention to those instructions. Do I know what exponential form is? It has exponents, right? So that might make sense. But take the time during class to focus on that. So you say, because guaranteed someone's going to be on a quiz and go, what's exponential form? And all I can say is, that's something you need to know. This is a quiz, right? Sure, it would be nice if on a quiz you'd say, what's exponential form? Oh, that's this, and this is how you do it. Oh, okay, thanks. And then next question, what does it mean to factor? Oh, that's when you do this, and this is your answer. Oh, thanks. Everybody would do really well. Bring. All right, here we go. A lot of people did the 1/2 and the cubed. Right? That makes sense. Always checking, right? When you're working on these. Always checking when you're working on these, does the step that I just wrote equal to the step above? If at any point you cannot explain and understand why the step below equals the step above, that's telling you you don't know the mathematics well enough. You need to study this and get better at it.
Or it just means we have trouble wording things?
No, if you can't explain it, then you need to, well, if you have trouble wording it, you still need to study it more. Because you have to be able to say, I know that these two are equal and why. Then 4 to the 1/2, I know that that's equal to square root of 4 and why. Square root of 4 is 2. I know why that is. 2 to the power 3 is 8. Okay?
You had no clue the implications of what I was saying.
Maybe I didn't. All right, I am going to